Hello, everyone. Good afternoon, and welcome to my Authcon 2025 talk about the unspoken trade-offs of fine-grained authorization. I really first want to thank Fusion Auth and all the other sponsors of this event for the first customer identity access management event. I think is a super important. I'll start with a short background about myself. My name is Gabriel. I'm leading the developer relations at Permit.io. I'm not new to access control. Actually, I started to work around authorization and permission in 2015, not at Permit.io, but in various products. But around 2 years ago, around that time, I gave my first customer meeting in my hat as the head of developer relations in Permit.io. And I my part of my pitch was something like this one. Authorization should be like authentication, same as you are externalizing authentication with Fusion App, let's say, you should do the same for authorization. And now, 2 years after, I know that I was really wrong, and I'm really sorry about the customers that I painfully led into that pitch. Not because you shouldn't externalize authorization. You definitely should externalize authorization, and we'll get to the reason a little after, but because authentication is not like authorization. That was a fundamental mistake that I had in mind. The same externalization should happen. But if we are looking on the differences between authentication and authorization, I'll not give the whole talk here. At the end is an IEM talk, so you all should know the difference. But authentication and authorization has fundamental differences. So for example, I just highlight some of the differences here, but every line on this table can show the different. Authentication, it's something that could be external. It happened once to the user. It controlled the session. It controlled what a user doing in application, but it has nothing with the business logic, with the application logic. Permissions or authorization is something that exists in every step that a user is doing something in the authorization. It involved with the application logic. It involved with the application data. And part of the difference between authentication and authorization is the trade-offs that we have to consider when we are implementing authorization in our application. And in more specific way, and we'll get to that later, in fine-grained authorization. But before we are diving into the fine-grained authorization thing, let's talk about coarse-grained authorization. Back when I started in 2015, I already worked in some sort of complex condition, but de facto what everyone has, and this is also a great model for today, is role-based access control. You are controlling what a viewer can see, what a user can do, what an admin can get, and that creates coarse level of authorization and permissions in your application. And it actually works great, but things happened doing that here. And today, fine-grained authorization is not an option, it's a need, it's a real need that actually every product need. And there are 4 trends that lead into the real need in fine-grained authorization on top of coarse-grained authorization. The first one is what we called cloud native. Even if you are one of these monolith guys, you must admit that you are using tons of microservices around your monolith. So software is built today from building blocks, especially in cloud native, that everything is run as a virtual something something. You don't have anymore your application code or your application logic. You're consuming API gateway from one external service. You're consuming data or persisted data from multiple services. You have cache services, you have messaging services, you have traffic services. I don't know, but your software is built from tons of micro components. And each one of them, not like authentication, has some implication of authorization in permission. It could be the data that you are permitted. It could be the type of the endpoint that the user is allowed to call in the API gateway. And all this one create more and more factors that we need to consider when doing authorization. The second one is the way that we are building software. Software is shift from building software that is driven by logic. Logic became a commodity today. You can get logic for free. I don't know if you got to this tweet. It was kind of a couple of months ago. It was a month ago. 2 months ago, on March, a guy who built a software product with Cursor that just started to work, find out that they need to save their API keys somewhere, and if they are authenticating the users but save the API key in the client side, then there is no real authentication. And the reason is that because what we are really building today in application is data-driven application. And it is not anymore one database that we are building with. It is actually tons of persistent services, that the new name for that. Persistent services. It could be the relational traditional database, but it could be also caching services. With our world, could be vector DBs, could be a lot of stores, and all this data need to be inspected to the micro level, to the really small levels of data, fine-grained levels of data, to determine what a user is allowed or not allowed to do. So the second trend is the amount and the types of the data that we are processing, and the fact that our application is driven by data and not logic. And that by definition create a need for more fine-grained decision that we should do. The third one is the way that we are deploying software. If you are in my age, you probably remember the left screen. When I started to work in software engineering to do a deployment, I pack my PHP package in tar.gz and copy the file from left to right. When I work as a freelancer, I did it multiple times a day. When I work in a large company, we all stay night once a month to do the nightly, to upgrade the version. Today, I'm pushing code to main branch, and then it automatically goes to production, even in very large company. Of course, there are methodologies to protect ourselves, but still everything is automated. And when we need permissions aspects everywhere in our application, we need to make sure that we are not just creating a coarse-grained infrastructure on top of our software, and we can track it, we can maintain it in a way that is externalized and fine-grained to our software. The fourth one, and I think this is the most important one, is the user requirement. User knows software. It is not like there is something on my phone that I can do something. User knows about security, they knows about privacy, and they knows about data ownership. And these three requirements became a basic requirement in every software. Talking about ownership, users really want to have an option for secure collaboration. Secure collaboration means that they can share their data, share some actions on their data, but in a level that they can define. Maybe even if you give them a coarse way to do that, you need to keep a fine-grained way to manage it. So we understand that we need it, but what differentiates between coarse-grained authorization and fine-grained authorization? So every policy decision, every decision that we do in authorization or policy decision is built out of three components. This example is a very generic check function. We have a binary check function. A user is allowed or not allowed to do something. And we have three components: the user, the action, and a resource. If we are thinking on a coarse-grained, it is all one parameter. We have one user, which is the identity of the user. We might have roles that actually correlated with that users, but we only consider the identity as one atomic part. We have the action, and again, atomic part of the action, the name of the action, let's say, read, and the resource type that the user is trying to read. This coarse-grained fashion, it actually even a little more fine than just writing your code if a user is admin, then return true, but it's still coarse-grained. We don't have a way to inspect better the data and the conditions that are actually part of this authorization check. When we go fine-grained, we are adding more factors into this check function. If we are looking on the users that we had, now we also passing some attributes about this user, real-time attributes. And if we are looking, for example, on the resource, we are now also passing the resource ID, and we are passing a tenant that the resource is a part for, or a resource that we are trying to check. So in a fine-grained permissions, we are getting to a way where we are having more and more factors, more than one factors on each or on one of the components in our check function. I think that's the most simple. I want to thanks to a good friend and a big name in the IEM community, David Brossa, that helped me to get that in a live stream we did a year ago. But I really like this definition. Fine-grained is where you start to put more factors, more vectors on your authorization decision. And because it evolves everywhere in our application, this is where the trade-offs start from. Before we are talking into the trade-offs, let's understand the two main niches in fine-grained authorization: conditions and relationships. It is actually two camps around software engineering. There are the one that goes only with conditions, the one that goes only with relationships. You may be familiar with these two camps from conditions as attribute-based access control, relationships, ABAC, or relationship-based access control, ReBAC. But let's understand what each of these terms meaning. In attribute-based access control, we are building our policies on top of conditions. We have a whole forest, and a user can get to a tree only if their profession is botanist, and the tree year, the plant year is 2014, and the time is between 8 a.m. to 6 p.m. That way, we are making sure that botanist goes only to trees that has enough time that they can check, and in the time that they can day in a day. So if it's on the night, for example, we know that this is not someone that's supposed to be in the field or in the forest right now. So on top of conditions, we are creating more and more vectors and factors on the data that we are trying to check, and the policy help us to get fine-grained decision. The other way around is relationships. Software is built on relationships. The first databases that's been used was relational databases. Graphs, trees, they are all very common in every software that we are using. And when we are thinking, how can we, without having explicit conditions, get a policy decisions, we can maybe trust, or we can trust on the relationships between the entities of our software. So in our software, we probably have explicit entities. So for example, we know that a user is a botanist of a specific tree. So for example, we know that a user is a botanist of pines, or for example. And then we also have loggers, and the loggers also have relationship to some trees in the forest. But then we get into an implicit way that we can use the relationship between the trees themselves to declare more and more conditions. So instead of declaring our conditions with plain policies, we are declaring our condition in a way that the data in our application control them. And choosing between conditions and relationships is something that is very common in people that actually doing that. Conditions and relationships became very common because of Google Zanzibar, a paper that Google released in 2018 and became like word of mouth of when going to fine-grained authorization. But in this slide, so if we're looking on this slide, relationship-based access control is, for example, OpenFGA and SpiceDB. These are engine for relationship-based access control, engine that based on Google Zanzibar. And there are also policy-based access control, policy-based engines like AWS Cedar. I work a lot with Open Policy Agent that is multi-purpose. It can get you conditions, and it can get you also relationships or data. So you can base data both on conditions and relationships together on one engine. I'll say that, for example, Cedar also supports some sort of relationships. OpenFGA supports some sort of conditions, but they are mainly based on relationship. So the first thing when we are thinking about how we get to the trade-offs, how do we think of the trade-offs, is by each of the approaches. If we are thinking on policy decision, any kind of policy decision, it actually based on three components. The first one is the policy itself. If we are looking on pure condition-based approach, this policy is the conditions that we are basing our decisions off. If we are thinking of data or relationship or Google Zanzibar engines, then the data will be the main part that we are considering. And if we are thinking on every decision, it also has context. So for example, the attributes that we are giving the decision, or the date and time now, which is not part of either the data that determine the decision or the abstract policy that allows us, that let us understanding the decision. I'll say that usually people say that Zanzibar has the trade-off of manipulating data and ingesting data into your authorization engine, but I think also ingesting policies and syncing policies is not something that you should not consider as a trade-off. So when looking at the pure high level, the main trade-off is how we are syncing, how we are making sure that our data is synced. I want to mention a project called OPAL, Open Policy Administration Layer. It's an open source project that we are maintaining in Permit, and it actually creates a control plane, a data plane for policy engines. You can use it with Open Policy Agent, you can use it with Cedar, you can use it with OpenFGA, and that gives you the top layer of syncing all the policy and data together. Let you just plug and play any kind of policy engines to your data sources and to your policy code and work with that. But with it, let's think about the main trade-off that we have when we are thinking of a fine-grained authorization, which is the consistency. We externalized the authorization. We have now a engine that is running somewhere, and this engine need data and need policy. And there are three main models of consistency that we can work with. The first one is strong consistency. The decision that I'm getting now is actually the most truthful for the data that is now is the policy engine. So for example, if the policy engine is waiting for data update, then the decision will take time. In graph-based, it could take a lot of time. So this is why we want to go sometime with eventual consistency, means if a decision is critical, we are waiting, but if not, we are taking the data that snapshot now, even if it's not the most up to date. Another option is to use read or write consistency, use only the data on the decision that you are trying to make. But the main trade-off here is that you can't centralize your data. All the data must be part of this authorization decision. So the consistency is another kind of trade-off that you need to consider, but that's not all, because in the real world, you'll usually have to combine between data and policy. In the real world, you usually have to combine between conditions and relationships. And this is the main trade-off that I wanted to talk about today. In this JSON objects, you can see a requirement we got from a large HMO, a permit client that is a large HMO, and they got with this requirement. You can see that there are three objects here. The first one is visit object, and the second is practitioner, and the third is diagnosis. I think the names is very straightforward. The condition for this policy is that a visit is allowed to read only if a visit is concealed. Do you remember we have here the attribute concealed on the visit? If all the diagnoses, or actually here it's some, but it should be, if all the diagnoses are not concealed, and if the practitioner is advertised. The only way to allow the user to read that is if all these conditions equal to true. Now, I'll not talk about the way I implement in this example, because that's not the way we want to do it. That coupled our application code with policy code, and it can have a lot of problems with data sync and etc. Let's talk about the right way to do this fine-grained decision in an external policy engine. So just to remind you, when we want to get a decision, we only have the visit by hand. We can also fetch the practitioner and diagnosis, but we have here relationships between the visit and the practitioner and diagnosis. And we also have condition. It all should be equals to true. This is actually, the condition here is quite simple, but think that the condition can be even more complex to that. And thinking about condition and relationships, we have three main ways to model this policy decision, and each one has its own trade-off. Let's start with a pure policy-based decision. The following code is code in Rego language. Rego language is the language that allows Open Policy Agent to run policy rule. And this code that we see here is actually declare what we are doing in our condition. It's actually declared the policy rule that we are trying to have. If you can see, we have here 3 defaults. The 3 defaults is equals to false, each one of them declared by a more complex condition. And the visit is allowed only if all these 3 components equals to true. If we see the top block of allow, this declaration means all these lines in this allow block need to be true. I think the first trade-off is clear. It is hard to maintain all these complex policies. Not only hard to maintain, it's hard to make it reusable. If we want to maintain code, if we want to keep clean code, the base requirement is to make it maintainable and reusable. So the first trade-off when you need to combine relationships and condition, that you could decide you're going with it, but the first trade-off is going with complex policy code. But what if we don't want to go with complex policy code for this one? So one of the things that we solve conditions in permit is something we call user set and resource set. In the traditional way of RBAC, of role-based access control, we are segmentizing users by roles, for example, admin, editors, viewer, etc., and segmentizing resources by type, documents, visits, etc. What if we can take each of these segmentation and make it dynamic? Instead of just call it in the name, put a condition behind that, and then this condition can be reusable and can a mix and match between resource set and user set. Here we can see, for example, the resource set of non-concealed visit, and we can see a user, which is a role. So we are using a combination of RBAC in the roles and ABAC attribute-based in the resource set. And then we keep a very simple conditions. So on one hand, we solved the first trade-off, but then we got to a new trade-off. When we want to evaluate a policy for such simple conditions, we need to imply some sort of policy condition in our application code. And this is also something we usually try to avoid. We try to avoid coupling between application code and policy code. So while we kept the policy logic simple and just configure it with simple flat 3 conditions of non-concealed diagnosis, non-concealed visit, and advertised practitioner, we had to make more complex kind of policy rule in our application code. So the other trade-off is instead of making complex policy as code, make complex policy rule. Now you might say, okay, you show us how you do it with conditions, but there is also relationship. Maybe you can model it in relationships because the diagnosis and visit and practitioner has a declared relationship between them. The problem is that relationship is also depend on a condition. And that means we need to create another item that will declare the condition. If you remember the way relation-based access control works, we are not doing a policy queries. We are doing a graph queries. We are going to a graph and ask, do we have the whole path to get between these users and this user and this entity? Here, we need to add more data to it. And in this diagram, I'll not go deep into this diagram, but what easy to understand it is the item that's called bool mark. When we are inserting our data and the relationship between our data, the relationship between diagnosis and practitioner, the relationship between visit and practitioner, we also make them all correlated, connected to a condition, a result of a condition. So when we are ingesting the data into our relationship graph, we are also massaging it. We are also manipulating it to be related to this fake condition. So the way to implement conditions inside a relationship-based graph means we need to manipulate our data before ingesting it to the graph. But on the other end, the enforcement is very simple because all what you have is just traverse the graph and understand what you are doing there. So we have 3 possible trade-offs. The first trade-offs is to go over the policy and make it complex. The second trade-off is go over the context and make the context complex or the enforcement code. And the third is to manipulate the data. So to summarize, for advanced fine-grained authorization, when we need to combine relationships and conditions, we need to consider what is the trade-off that will work best for this access control model. I'll say that one of the things that we did to make the life of our customer a little better is to create first level relationship that is also condition based. So we have a JSON language to declare conditions that is kind of less complex than Rego language because it's very declarative without the find of the logic. And we added a foreign key field, as you can see here, a foreign key resource type, which create the first level relationship, but the relationship must be explicit and must be only in one level. So kind of some summary of what we have here when we try to keep the trade of fine-grained authorization. First, we need to externalize, we need to use policy-based authorization system, no matter if it's based on condition or based on data. It's something that our application needs. We need to keep the policy code as simple as reusable as we can, minimizing the data manipulation, decouple the policy and the enforcement, and the most important part, understand the trade-offs of each of these sides and make sure that we are doing the thing right. Everything that I talked today is also available in this article. You can find there the diagrams, the code samples that I show, and some more blurbs that I gave on that topic. Thank you.